In this video, we'll change the wavelength of the Euler sine function with values of W from 6 to 12. So data validation. List of items. Say we start from 6. And the Euler sine function with this array formula. Complex. That's 0 plus wxi. So 0, comma, w times x. Another. So this is 0 plus wxi, so complex 0, comma, wx. And there's an Euler part, so it's the Euler's number raised to the power the complex number. So e raised to the power 0 plus wxi. So this will be IMEXP. IMEXP. And finally, we only want the imaginary part. So we use the function imaginary. And we continue with the Taylor series sum function, which is sine of x raised to the power w times the summation of a times cotangent x raised to the power n, where n starts from 0, incremented by 1, and the value of a is array formula combine. So this is array formula. Combine w comma n. That's the first part. The second part is sine w minus n times pi over 2. So this is 0.5 pi. So sine 0.5 pi. And this will be w minus n. So the quantity w minus n. We close the sine function, and we close the COMBIN, the array formula. We correct this. So if n is greater than w, it should be 0. So if n is greater than w, it should be 0. Because it's only n up to w. So if n is greater than w, 0. Otherwise, calculate. Now it's corrected. Now we continue with the expansion, which is, we begin with the series sum, array formula, series sum of the cotangent x, cotangent of x raised to the power n, where n starts from 0, incremented by 1, and the coefficient will be this range. And we continue with the second part. The second part will be, it's multiplied. So sine of x, that's sine of x raised to the power w. W. So that's sine of x raised to the power w. And we correct this. If x equals 0, it should be 0 because it's sine. So if x equals 0, it should be 0. Otherwise, calculate. Now it's corrected. You can now chart this. Insert chart. And we use scatter chart. Use scatter chart. We don't need this. We show the trend line. Under series, show the trend line. The type polynomial. The degree tenth. For the label, use the equation. And we will, for the legend, position on the left. So here's our trend line and polynomial of the Euler's sine function. We cannot change the value of w to 7. We'll change also the expansion to 7. The Euler sines w to 8. We'll change the expansion to 8. We'll change this to w to 9. We'll change also to 9. Change the Euler sine function to w to 10. We'll change it to 10. So we shorten the wavelength further. W goes 11. We have a shorter wavelength now. Then you change the expansion to 11. And we'll change it to 12. So we have a very short wavelength. We should also shorten it to 12. This completes the use of the functions series sum, cotangent, sine, IMREAL, complex to generate or to change the wavelength of the Euler's sine function.